Welcome to another session of Ebenezer Gate coaching classes. This is a numerical aptitude type problem for 2 marks. Consider the network shown below with R1 equal to 1, R2 equal to 2, R3 is equal to 3. The network is connected to a constant voltage source of 11 volts. The magnitude of the current through the source is. So this is a problem where you'll have to use the symmetry. Now, when we look at the circuit from here, this point and this point are same. So it can, whatever happens, if you divide this, draw a line here, there is a symmetry. Means this side and this side are same. So whatever voltage is there here, you'll have the same voltage here. Whatever voltage you have here, you'll have the same voltage here. So so this voltage is 11 volts. This is 0. So this is 11, this is V volt. So the current that's going here will be same as the current that's going here. And similarly, the current that is going here is same as this current that is going here. Now we know that the current that enters here will come out here. So whatever the current is, let's say this current is I, this will also be I. So with these assumptions, let us solve this. So let us write the equation here at V1. So when we write that equation, note V1 minus 11 by R1 1 plus V1 minus V1 by R2 plus V1 R2 is also R2 is 2 plus V1 minus V2 by R3 which is 3 plus V1 minus V2 by R1 which is 1. So V1 by minus 11 by R1, V1 minus V1 by R2, V1 minus V2 by R3 plus V1 minus V2 by R1 is 0. V1 minus V1 is 0, so it is V1 by 1, V1 by 3, V1 by 1. I multiply the entire equation by 3, so I get 3V1 minus 33. This term goes plus V1 minus V2 plus 3V1 minus 3V2 is 0. 3V1 plus 3V2, the V1 plus V1 is 7V1 minus V2 minus 3V2 is minus 4V2 equal to 33. This is one equation. Now we also know that the current that comes out is same as the current that goes in, and also because of symmetry, this current, the current that passes through R1 here is the same current that passes through R1 because of symmetry. Let me explain it. So whatever enters, suppose whatever enters is, let's say, X. So what comes out is also X. And because of symmetry, X by 2 goes here and X by 2 goes here. The same X by 2 comes out here, same X by 2 comes out here. So V2 minus 0 by R1. So whatever comes out, that is V2 minus 0 by R1. R1 is 1, is also same as 11 minus V1 by R1. V1 by 1. So V1 plus V2 is equal to 11. This is equation number 2. So once you find V2, we can find this current. Once you find this current, that into 2 will give you the total current. So V1 plus V2 is 11, V1, 7V1 minus 4V2 is 33. So I multiply the equation 2 by 7. So I get 7V1 plus 7V2 is equal to 77. I name it 3. So I subtract equation 1 from equation 3, I get 7v2 minus 4v2, that is 7v2 plus 4v2 is equal to 77 minus 33, that is 44. So this is to 11v2 equal to 44, or v2 is 4. So v2 is 4 means v2 minus 0 by 1, that is 4 amps. So this current I, whatever I mentioned here, x by 2, whatever I mentioned, x by 2 is v2 minus 0 by 1, which is 4 by 1, which is 4. So x, the current that comes out of the source, is going to be 4 into 2, which is 8 amps. So the answer to the problem is 8 amps. Thank you. God bless you.